Hi again, guys. We are moving on in our stoichiometry unit, and we're going to start talking about volume to volume stoichiometry. So now we're going to be using actual measurable units for each of our components of our chemical reaction, and then we want a measurable unit at the very end of that chemical reaction so we can make a prediction about either how much reactant we need or how much product we will get. So moving on in your notebook, you're going to the next page. We're doing page 26. In your index, you should say volume to volume stoichiometry, page 26 under box V. So again, you should be like watching the video, pausing when you need to and hitting play. And the advantage of the delivery right now is that you can go back. What did she say? Or give me a second to write this down, so you can go at your own pace. But definitely always start off by keeping up with your index, so we can make sure that you can get to the pages you need to very quickly as we are moving through this unit and you need help or assistance, okay? So again, now I am in page 26. I have the date and volume to volume stoichiometry. So I have you writing this graphic again because we are going to continue to use the mole to mole roadmap here as we're looking at stoichiometry, which again, we would use this when we're looking at exact quantities of reactants and products and trying to relate them to each other. So what we're going to do today is I will give you an amount of liters of one of the substances in your chemical reaction. You're going to have to convert that to moles, which you should already be pros at doing. So this step isn't very difficult to do. You're going to use that constant 22.4 liters in 1 mole. And then you will go from moles of the substance that I give you to moles of the substance that we are asking about, by using, again, the mole-to-mole ratio, which we've been practicing for the last few days, and you should feel comfortable doing this step as well. So then once we're in this second substance, we will again have to go back out into liters by doing a mole to liter conversion, which again, you guys have done several times. You're just using this constant 22.4, and you should be able to do this conversion as well. So if you think about it in different chunks, you could think about the fact that this is just a one-step liter to mole conversion. This is just a one-step mole to mole conversion here. And then this is just a one-step mole to liter conversion. We're just putting it all together so that we can plug into our calculator and get one final answer by the end, okay? So the next thing I want you to write down are the steps that you're gonna take when you are completing these problems. You're gonna first start with what's given. That's always what we do in that very first step. We're gonna second convert to moles. You will use this number to do that. Then you're going to use your mole-to-mole ratio to get to your second substance. And then very last thing you're going to do, fourth step, is going to be convert to the units desired, which all of the questions today are going to leave us with liters at the end, okay? You will see moving forward that we're going to go from grams to grams. And then there's possibly going to be some mixtures of liters of one substance, grams of another, or liters of one substance, or I'm sorry, grams of one substance, liters to another. So the first problem that I'm going to give you guys today is going to be NH3 and oxygen, or ammonia and oxygen, yield nitrogen and water. So take a second, pause the video, and balance this chemical reaction. Okay, so, you should have gotten, I guess I did both at the same time. 4, 3, 2, and 6. So again, make sure you guys are able to balance chemical reactions. It's going to be the first step to basically all the questions we're going to do from here on out. So my question is, what is the volume of ammonia, NH3, that will react with 22.5 liters of oxygen? So once again, you can see that I am boxing the information that I'm given. So I know this is definitely going to go in that first step. And I circle where I want to go. so that I know that I am starting at liters of one substance and I want to end up at volume or liters of another substance. So in following the roadmap, which again, I don't want you guys to write this down per se. Again, I just want you to look back in your notes at it. You know that you're starting at liters, going to moles, going to moles, going to liters. So this graphic should help you know what you're plugging in and when. So always and forever, I take the information that was given and I go ahead and I put that in my very first step. Okay, and let me clarify for a second too here. The reason why I have drawn my train track and I've drawn 1, 2, 3 tracks in my train track is because I'm going to take 1, 2, 3 steps in my roadmap, as you can see. So the very first thing I have to do is I'm going from liters to moles, right? So if I go from liters to moles, I'm going to always have to say what goes up must come down. So liters of oxygen was at the top. Liters of oxygen goes on the bottom. And I'm trying to get 2 moles of oxygen. So my unit desired goes at the top here as moles oxygen. Okay, so you can see from the units I've set up, I'm changing from liters of oxygen to moles of oxygen. All right, now I have to think about what numbers I'm going to plug into this conversion factor. Now, this right here is just a conversion. Okay, so I need to think about how many liters are in a mole for a conversion. So there are 22.4 liters in 1 mole of oxygen. And we should remember this from the mole conversion unit that we've done. Okay, now my equation has gotten me to moles oxygen. Ultimately, I want to get to liters of ammonia. So this is the step at which I'm going to go from moles of one substance to moles of the other using that mole to mole ratio. So once again, moles oxygen is on top, moles oxygen goes at the bottom. I'm trying to change to moles of ammonia. So I'm going to write moles of ammonia at the top. All right. And that's because I'm at this step right here. Okay. What numbers am I going to plug in? I'm going to plug in the mole to mole ratio. So to get the mole to mole ratio, you guys should remember that you are looking at the coefficients in this balanced chemical reaction. So oxygen in my balanced chemical reaction has a coefficient of 3. So in my equation next to oxygen, I'm going to put the number 3. Ammonia in my balanced chemical equation has the number 4. So in my calculation here, next to moles of ammonia, I'm going to put the number 4. All right. So just to summarize where we are at this point, I have gone from liters of oxygen to moles of oxygen. And now with this last step that we just did, we went from moles oxygen to moles ammonia. All right, last step is I want to get to volume of ammonia, not just moles of ammonia. So I'm going to have to do a mole conversion here, So I'm going to say once again, what goes up must come down. Moles of ammonia was on the top, moles of ammonia is on the bottom. And as you can see, I've already started to cross off these units because what goes up must come down so that the units can cancel out. And then at the very top is going to be my last unit desired, which is going to be liters of ammonia. Now I have to figure out what numbers I'm going to plug in next to these units. And because this is a mole conversion, I'm thinking about how many liters are in 1 mole. So next to the mole is going to be 1. And how many liters are in a mole? 22.4. All right, now the math is exactly the same. It should be very straightforward and something that you can always do with a calculator. So you're going to take your calculator out and you're going to take everything that's across and see how I've put this in parentheses. I'm going to maybe type into my calculator parentheses 22.5 times 1 times 4 times 22.4 because we take everything on the top that's across from each other and we multiply it. We're going to do the same thing at the bottom. See how I've put parentheses around my numbers down here as well? I want to know what the entire bottom row multiplied together equals, and I'm going to take the top answer that I get, and I'm going to divide by the bottom answer. okay? So in your calculator, you're going to want to type parentheses 22.5 times 1, same thing. You don't even really need to type that, times 4 times 22.4, close your parentheses. Then you can hit divide, parentheses 22.4 times 3. And again, you don't necessarily have to write times 1, but if you would like to, you can. And then close your parentheses. If you enter everything into your calculator correctly, which I suggest you try it out on your own just to make sure that you're not goofing up, you should get 30 liters of ammonia. Okay, so let's try that with one more, just to make sure you guys have that process down before you thinking. Pair share it. And we're going to say with that same exact equation, what volume of oxygen will react with 47.5 liters ammonia? So once again, this is the information I start with. This is the information where I want to go. So I know this time I'm starting at my ammonia value, and I'm trying to get to an oxygen value. Okay, so let's put the numbers that we started with at the top. Then we know what goes up must come down. And in this first step, I know I'm going from liters to moles. So I know that the unit at the top is going to be moles of ammonia, okay? The numbers here are a conversion factor. I'm just trying to get from liters of ammonia to moles of ammonia. So I use 22.4 liters of ammonia in 1 mole of ammonia. And that will get me out of liters and into moles. Now I can switch from moles of ammonia to moles of oxygen, moles A, moles B, by using this mole to mole ratio. In other words, the coefficient in the balanced chemical reaction, right? So what goes up must come down. We're going to write moles ammonia. And the units I'm desiring in this step is oxygen. So we're going to say moles oxygen, right? To plug these numbers in, I'm looking at my chemical reaction, okay? Moles ammonia in my chemical reaction has a 4 next to it. So in my calculation, I'm going to put 4 next to moles ammonia. Moles oxygen in my chemical equation, there's a 3 here. So I'm going to put a 3 in my calculation. And at this point, I have now switched from talking about moles of ammonia to talking about moles of oxygen. So the last thing I'm going to need to do is convert that mole of oxygen out into liters, right? We want ultimately to get volume, which is measured in liters. So the last step is going to once again say what goes up must come down. So moles of oxygen is at the bottom. And the units I desire in this particular step is liters of oxygen. So then I have to use my conversion factor to change moles to liters. And so in 1 mole of oxygen, there are 22.4 liters of oxygen. Okay, so once you've set this up correctly, it's once again just a matter of plugging it into your calculator. We're going to say parentheses 47.5 times 1 times 3 times 22.4, close the parentheses. Then we're going to hit divide so we can divide by the bottom, and we're going to go parentheses 22.4 times 4 times 1, close the parentheses. Okay, if you plug that into your calculator correctly, you should get 35.6 liters of oxygen, right? So that means you guys are ready to do a practice on your own. You should be working on the left side now. So on the left side of your notebook, you should label this as 26A. Your thinking pair share is going to start with the equation you have seen before, water decomposing into hydrogen gas and oxygen gas. Pause your video and balance this chemical equation. Okay, this is what your chemical equation should look like if it's balanced properly. It's not a tough one. Hopefully that one was quick for you to do. Here's your stoichiometry question that is going to be associated with this particular chemical equation. I would like for you to calculate how many liters of oxygen from 6 liters of water. So I've already started you guys off. What I would do on your page is I might box this and underline this. I have started you off by putting 6 liters of water in the front, and I have set up your stoic problem. Remember that what you're going to do here is convert to moles of water. What you're going to do here is you're going to use the mole to mole ratio to get to moles of oxygen. And what you're going to do here is you're going to convert from moles of oxygen to liters of oxygen. So pause, try it out on your own, and check the answer. Okay, so you should have said at the bottom here that liters liters water, there's 22.4 liters of water in 1 mole of water, okay? Then you're going to say what goes up must come down again, and there's actually 2 moles of water, right? 2 moles of water for every 1 mole of oxygen in this chemical equation. Then what goes up must come down. In 1 mole of oxygen, there are 22.4 liters of oxygen. And if you plugged all of this into your calculator correctly, you should have got 3 liters of oxygen ultimately. Okay? Something else I would like to clarify here is the reason why this is 1 mole of oxygen is because there is 1 coefficient in front of oxygen, okay, in the chemical equation. The reason here why it's 1 mole of oxygen is because we are converting from moles to liters. And in that case, you always use the conversion factor that 22.4 liters is equal to 1. Okay? So once again, these are going to be your steps every time for these problems. First, convert to moles, then use your mole to mole ratio, and then convert to liters. Okay? Thank you.